Hello everyone. Let us discuss one numerical on FRIIS formula that we have just now derived. Consider the connection of two systems. One is amplifier and one is mixer. The question says in a radio receiver and RF amplifier, which is this, and a mixer, which is the second block, are connected in cascade as shown in the figure. The amplifier has a noise figure of 10 dB. So what we are given is the noise figure of the amplifier, which is 10 dB. Now please remember that we are using notation F, which is also the notation for noise factor. But let me remind you that noise factor when expressed in dB is nothing but noise figure. So when noise factor is given as 10 dB, I can also call it noise figure of 10. So there's a noise figure of 10 dB and the power gain is also given in dB. It is equal to 15. Please remember in all the formulas and whatever derivation that we have done till now, the power gain that we had used was not in dB, it was the normal value. The noise figure of the mixer is given as 20 dB and no power gain of the mixer is given. Generally, the power gain of mixer can be assumed to be 1 because it is not doing an operation of amplification. So ideally it should give us the power gain of 1, but it may happen that power gain is less than 1 as well. Never mind, we don't need the power gain of the last stage in the FRIIS formula, if you have observed that. The noise figure of the mixer stage is 20 dB. We have to calculate the overall noise figure referred to the input. So we have to calculate overall noise figure of this entire structure. So let us see how we can solve this particular expression. Whatever values that are given to us, f1 equal to 10 dB, we'll have to convert it into a normal value first. So f1 in dB is nothing but 10 log of f1 to the base 10. So whatever value they have given, let me put the suffix dB to differentiate between the dB value and the value that we are going to derive. So f1 in dB is equal to 10. So 10 is equal to 10 log of f1 to the base 10. And if you solve this, 10 will cancel out. So it's 1 equal to log of f1. And how will you get f1 from this? You have to take anti-log of 1, or you can simply use this value and the power here. It becomes 10 raised to 1. So that will be equal to 10. So we got f1 as 10. Similarly, f2 in dB is given as 20 dB. So let's convert it into a normal value. So f2 dB will be equal to 10 log of f2 to the base 10. f2 in dB is 20 equal to 10 log f2 to the base 10. Now this time 20 by 10 will give you 2 here. So 2 is equal to log f2 to the base 10. And therefore f2 will be nothing but 10 squared, which will be equal to 100. So we have got the values of f1 and f2. Similarly, we will also have to convert g1, which is in dB. We'll have to convert it in normal value. g1 in dB is given as 15 and g1 in dB will also be equal to 10 log g1, where g1 will be its normal value. So if I go through the similar steps, then I can get the value of g1 as, so 15 equal to 10 will be nothing but anti-log of 1.5. So 10 raised to 1.5 will give us 31.62. So that's the value of g1 that we have got. We have to now calculate overall noise figure. To calculate overall noise figure, we first calculate overall noise factor. Overall noise factor is given by the FRIIS formula as f is equal to f1 plus f2 minus 1 divided by g1. f1 is nothing but, you can see we have got the value of f1 as 10. So 10 plus f2 was nothing but 100 minus 1 divided by g1 value is obtained as 31.62. So if you solve this out, you get overall noise factor f equal to 13.13. But we have to calculate noise figure, and we know that noise figure is nothing but noise factor in dB, which will be 10 log of f to the base 10. So that will be 10 log of 13.13. And therefore my final answer, which is the overall noise figure, will be nothing but 11.18. And obviously this is mentioned in dB. So when I take log of 13 and multiply it by 10, you get 11.18. So that's the final answer. That's the noise figure that we were asked to find. If the question says find overall noise factor only, then we can find the value of f and stop here. This will be my final answer. Most of the times all the values of noise factor and power gain will be given in dB. So in that case you have to go through this standard procedure of converting dB value into the normal value.